What are multi-fiber push-on connectors or MPO connectors? Why are they important today in this data-hungry world? And what are 5 essential things you must do to ensure the best performance of your MPO links in your network? Hello, friends. Welcome to Todofibra Optica. This is a platform where we try to talk to the experts and the leaders of the industry to talk about the latest in fiber optic technology, trends, best practices, and anything that can help us bring fiber to every home in the world. I'm Jose Enriquez, and today I have the pleasure of welcoming Guillaume Lavallee from EXFO. Hi, Guillaume.
Hello, Jose. Thank you for having me today.
Thank you for being here, and welcome to Todofibra Optica. So to get started, let me tell you a little bit about EXFO. EXFO is basically a test and monitoring and analytics solutions provider for the telecom industries. In a sense, EXFO is a company that helps telecom owners and builders ensure that the network is built properly with the highest standards to ensure quality and top performance of the network. So to get started, let me introduce you to Guillaume. He has over 15 years of experience in the telecom industry, specifically the last 15 years in the test and measurement related technologies and its best practices. So I think he's the right person to give us more insight into this type of MPO connectors and how to properly inspect them, install them, and make sure that they perform at its best. So Guillaume, if you could tell our audience a little bit about you, your trajectory, and what is your current role at EXFO, please go ahead.
Yes, thank you. So my name is Guillaume. I'm based in Quebec City, Canada. That's the French part of Canada. That is where EXFO has its headquarters. So EXFO, you mentioned it, we're specialized in test and measurement and monitoring. We've been around for over 37 years, and we work with operators across the globe. So our goal is really to help the operators be efficient in their deployments, avoid any problems, assure the quality of the network, make sure everything is good, performing correctly, to avoid any problems or complaints from customers. So that is really our field of focus. And my role at EXFO is solution manager. So I'm looking at the portfolio of solutions we have to make sure we always stay on top of the latest technologies, that we have easy to use and efficient solutions for our customer to test their network and ensure the quality of it.
Perfect. Thank you, Guillaume. And moving forward, basically, Guillaume wrote recently an article on 5 essential things you must do to ensure top performance of your MPO links. But before we dive into these essential things you must do, for our audience who may not be familiar with MPO connectors, could you give us a broad overview of what are the MPO connectors and why are they important in today's data-hungry world?
Yes, MPO connectors, they refer to multi-fiber push-on connectors. So those are fiber optic connectors for multi-fiber links. So the particularity is that in a connector, such as the one I'm holding here, so you have multiple fibers here that make a contact at the connection point. So in the cables where you have a MPO connector, there's multiple fibers. So it comes in different variants. You can have variants of 12, 24, 16, and a few other ones. Those are the main ones, but the essential characteristic is that you have multiple fibers in a small connector. It's really sensitive with a really small core where the signal is traveling. So there are specific tests we recommend to do when manipulating those connectors to ensure you have a good quality of service.
Perfect. I think I would only add there that I think the importance of these connectors being so small and with more fiber density is that, you know, data centers have a fixed volume, right, and capacity, and every day we need to add more capacity, we need to add more rack space, and we need to put everything in a smaller footprint. So that's why these connectors are becoming so important, have become so important in today's world of data.
Yep, absolutely. I mean, the density is the key driver for this. So the fact that you can have so many fibers in such a small footprint. It's the main driver for its adoption. You mentioned data centers. We've seen it in data centers as that had been there a while. We now see it a lot in other environments. So when we talk about central offices for telecom operators, head-end for MSOs, we see it also. There are other variants. You have ruggedized connectors used outdoor in FTTH with the similar multi-fiber footprint. You also have some of those cables also used in the cell towers. So in the riser cable to bring the connectivity from the baseband station all the way to the remote radio head, you see some variants of those multi-fiber connectors. It's all driven by this need to have a denser solution, right? Something that includes multiple links, but in a really small footprint.
Perfect. So, well, moving forward, let's dive into, the 5 things you must do to have a proper MPO link. So if you can guide us, starting with how to inspect the MPO connectors and the rest, please go ahead.
Yes. So the first thing is connector inspection. So what is connector inspection is we would validate that there's no particle that obstrudes any of the fibers in there. So of course, it's really small, right? So here in the one I have in my hands, you have 24 fibers in there. So it's not possible just with the naked eye to assess if the connector is damaged, if there's debris, if it's dirty. You have a really small fiber core. So in this case, it's single mode fiber. So it's 9 micron, the size of the core. So it's really, really small. So you'll want to look at particles that go as small as 2 micrometers to validate, is there anything that would block, let's say, the signal? So that would create loss. Or is there any particle that would create a reflection, unwanted reflection? So those things can in turn create a bit error rate, affect the system performance, the network reliability. So to assess this, there are different specialized tools that we call fiber inspection scope. I have one here in my hand. So really it's a tool that's a specialized microscope that would take a picture of the really small connector end face here. It would then identify where the fibers are and apply industry standards. So there's an IEC standard on connector hygiene and give you a pass-fail on every one of those fibers. So you know exactly if it's good, perfect, you can connect it. If it is bad, most of the time it would be because it's dirty. When it's dirty, there are different tools available on the market to clean a connector. Specific fiber optic specialized tools. They are really sensitive. They cannot be cleaned with anything, right? Just a piece of tissue wouldn't work. In fact, it would make it even worse than it was. So then you would need to clean it using proper cleaning material to make sure it's good. There's nothing obtruding this connector. So inspecting and cleaning, they go hand in hand, because the first step before connecting is always to inspect. If it's good, you can connect it. If it gives you a bad result, that's where you would clean it. And the cycle could be repeated a few times because it can take more than one attempt to clean a connector. So we see customers doing it 3 to 4 times before then deeming, okay, maybe if after 4 times it's still not passing, maybe there's a deeper problem with the connector itself. But it takes a few attempts. So we said 5 essentials. So I named 2, the inspection and the cleaning. There's another element.
I have a question. Sorry to interrupt you.
Yes, absolutely.
Well, on the inspection part with this tool, the inspection scope.
Yep.
When you have these 24 fibers in that connector, does the connector detect each fiber individually? Does it tell you exactly which link is the one that has dirt on it?
That's a good question. The answer is yes. So a tool like this is an automated tool. So it would take a picture of the connector. So you just press a button. Within 10 seconds, it gives you the assessment and you have the verdict per fiber. So if you have 24 fibers, it's going to analyze each and every one of them and give you a pass-fail on the overall connector, but also on the individual fibers. So you will know which of those fiber link is faulty in this case. Yes, absolutely.
Perfect. Thank you.
Okay, so we talked about inspection, we talked about cleaning. Another important concept with multi-fiber connector is the polarity type. So in a cable like this, as I said, I have multiple fibers. So this one is a 24 fiber. There are other variants that exist. So for example, here I have another one which is 12 fibers. And in there, you can have different fiber paths. So those fiber paths are what we refer to as polarity type. So you can have a straight cable. So the fiber on one side on port 1 goes to port 1 on the other side, port 2 to port 2, 3 to 3, so on and so forth. So that's a straight cable. It's polarity type A. Then you have other polarity types. Polarity type B is reversed. So in this case, it means that fiber 1 goes to fiber 12 on the other side. Fiber 2 goes to 11, 3 to 10, so on and so forth. And type C is flip pairs. So each pair is flipped. So fiber 1 goes to 2, 2 to 1, and then next pair, 3 to 4, 4 to 3, so on and so forth. And there's also a new type, type U, that is a bit different, that is coming in the new release of the standards. So those different polarity types, they're there to allow the network architect to have some flexibility when designing the network. But the potential cause of problem, and in fact, is something we've seen about 30% of the customers manipulating this type of cable reporting having problems with that, is if it's mixed. So if you're expecting a type A, but somehow the cable was reversed, not using the right cable type or not the right bulkhead types, because there are different bulkheads that could reverse the polarity type. So if it's the wrong polarity type, it means the light won't go where it's supposed to go. So the transmit won't talk to the receive, and the system will not work. And the worst with this is that it's really hard to troubleshoot after the fact. It's something at the time of install we recommend to test, because then you go and you can know which section was faulty if that's the case. Because if you only find it after the fact, it's hard to troubleshoot. It's not something a tool like an OTDR could not detect this. So you need to kind of, work on a sequence by sequence to find where the problem is. So it can be really time consuming. So that's why it's really important to validate the polarity type at the time of install.
Is there a question there? Is there a specific type like type A, B, or C that is more common than the others, or do they vary a lot? And who decides what type of polarity you need in your data center or network?
That's a good question, Jose. I would say it would depend of the operators. It depends of where in the networks those are found. So we said, there are different places where you can find those connectors. We often see type A and type B. Type C a bit less, but again, it would depend of the application and where it is used. And it would depend really on the network architecture. So they exist, they are available. It's like, for example, when you have different possible fiber types or connector types, but it's, so they can coexist also.
Excellent.
Okay, thank you for the question. So the three steps. Then another one, it's continuity confirmation. So continuity might sound simple. It refers to if the light goes from A to B. Is it going where it's supposed to be? But that's a really important thing, because we see cases of tracing, the light's not going where it's supposed to. One of the cause of problem could be the polarity type, but to validate the continuity, typically you need to do an end-to-end test. So I have two testers, one at each side to validate, okay, it's really going from side A to side B. There's light all the way to the end. There's no mix in fiber. There's no break within this length. So it's an important thing to validate. And then the fifth thing is really linked to the loss measurement. And this is linked to tier 1 testing. So it's to validate, is my end-to-end link within the loss budget that I have? And when you do this test, it's typically with an OLTS, optical loss test set, which would include a light source on one side and a power meter on the other side. So the light source would emit light and the power meter validate the power level. And the first step to do when you do this loss testing is to reference the units together. So you would reference them together with a patch cord in between. So basically you zero them out, and then you put the cable under test. So you validate the loss of this actual cable. I talk about the reference procedure because that's a center element when you do this loss measurement. That's a step you absolutely need to do. And it's also the main cause of error. So in other words, if when you do the reference, there's a mistake there, then the loss measurements you'll do after that won't be the right one. There are different reference methods that are available in the industry and described in the standards. The most precise one, the recommended one, is the one cord reference. It's simpler, just one patch cord between the source and emitter. And it's recommended because in your measurement, in your loss measurement, it would include the loss attributed to the first and last connectors. And we said initially the connectors are really important, really sensitive to dust and particles. So you want to assess the overall loss with those connectors as well, because they'll be good contributors to the overall loss of your link. So you want to take this into account. However, particularities of the MPO connectors is that you typically have one side without pin and a side that has pins. So those are guiding pins and alignment holes on the other side, so that we said there's a lot of fibers in a small footprint, so it needs to be really tightly aligned. So you have this concept of male and female connector when you talk about MPOs. So to go around this, you might need other reference methods. There's one that is called the adapter cord. So basically you add a small adapter cord after the reference to change the gender from male to female, male being the pin connectors and females being the unpinned connectors. This is a bit less precise than a one cord because it would include the loss of just one of the two connectors. But still, sometimes you'll need to do this because of this gender you wanna take into consideration when working with MPO connectors.
Excellent. Well, and another question that I have is, considering this is a relatively new technology, at least for many of us, what sort of training and professional, skill level do the professionals that do this testing required, and what sort of support is required to really help them do a proper job?
The tools to do the testing are designed to be automated. They are designed to guide the user with step-by-step methods. For example, the reference process I mentioned, it's a bit, it's important to do it properly. So in the tools, you have a reference assistant that guides you on which manipulation to do. So the tools, the more we go, they're easier to use. They're, automated with really intuitive user interface. So it helps. However, if someone has to do this type of installation of MPO links and to do the testing, it's important to have a basis in fiber optic fundamentals. There are some particularities of when manipulating optical fibers. For example, you'd never want to touch the connector in phase because it's really sensitive to dust. You want to leave it protected with the cover. When you do the install, you don't want to bend the fiber too much because it could create a macro bend and have unwanted loss coming out of the fibers. Then there's the concept of polarity I mentioned. There's the concept of gender from the male connector to the female connector. So there's a few particularities. So it's always recommended to have a fiber optic training. If you've never manipulated such cables, you want to have a training to know what to do, what to avoid, what are the best practices and all that. But once you have this basis, then after that, as I said, the tools are conceived to be easy to use by everyone. So you don't need to be an expert to do this type of work.
Perfect. Before I forget, we will put the links to the article that I was talking about right below, so you can check them in both English and Spanish. And likewise, if you want to see more content like this, you can subscribe to our channel, and we will be doing a lot of these interviews in the next few months. So please subscribe. And Guillaume, I don't know if you have any closing remarks or any final thought or tip that you would like to share with our audience.
Yes, maybe I'll close it by saying that the testing piece is always something we recommend to do at the moment of install. because if those steps are skipped, then it can create a lot of troubles after the fact. And troubleshooting is always more complicated than if everything was properly done and followed at the time of install. So we always recommend to follow those testing best practices. And the more we go with the systems that are going with higher speeds, the more sensitive it'll be, right? So with the fiber installs, we said, hey, in data centers, central offices, that's where we're going with higher rates, moving to 100 gig, 200 gig, 400 gig. And the higher you go, the more sensitive it is to those potential cause of problem. So it makes it even more important to ensure that everything is properly tested at the time of install to avoid problems now or problems in the future when the system is going to be upgraded to higher data rates. So that would be my recommendation.
Perfect. Thank you, Guillaume. And well, I hope you have found this information useful. Please leave your comments or questions in the comment section below, and we will try to get back to you as soon as possible. If you have suggestions on what sort of content you would like to see, what questions you have, so we can ask the experts, please feel free to leave them there as well. Thank you, Guillaume, and thank you, friends. See you soon.
Thank you, everyone. Bye-bye.
Bye-bye.